Section 2, Tables and Queries in ArcMap. In this section, we'll learn how to work with tabular data in ArcMap and merge that tabular data to spatial data using joins in ArcMap. You'll also learn how to query spatial datasets based on their attributes, and you'll learn about basic data exploration through visualization. Exploring tables in GIS data types. In this video, we will learn about nominal, ordinal, interval, and ratio data. We'll then learn how to import a CSV file into ArcMap, and finally export data to a geodatabase. First, I'd like to discuss briefly the topic of attribute data. In particular, attributes in a GIS concern what we're mapping. You'll remember from previous videos that GIS layers are characterized by an attribute table. Your layer is going to have features, which represents the geometry of each particular object in your GIS dataset, but also attributes, which looks a whole lot like an Excel spreadsheet in which each feature is represented by a row and each column represents some characteristic of that feature. Generally speaking, we work with 4 different types of attributes, or levels of measurement, as they're sometimes called in a GIS. These include nominal data, which we can think of as descriptive information or qualitative information. Ordinal data, which refers to rank orders. Ordinal data doesn't give us any information about the distance between different ranks, but rather it gives us a sense of which are maybe larger or smaller or higher or lower. Interval data represent data that are additive but don't have a true zero. And so what this means is interval data might be something like Celsius or Fahrenheit temperature, in which 0 is a legitimate value, but doesn't mean an absence of temperature per se. Finally, ratio data are data that do have a true 0. As such, 0 represents an absence of that quantity. This could mean income, in which 0 income means no income. As such, a ratio scale is both additive and multiplicative. Commonly in a GIS, you'll be working with nominal data and ratio data. Here's a brief example of nominal data. For the continental United States, the 2016 presidential election results. In the United States, presidential elections are determined by an electoral college in which the victor of each state is granted votes in accordance with the number of electors that represent each state. And so, in the US, states are commonly characterized as red states, in which the state was captured by the Republican candidate, which in this case is President Donald Trump, or blue states, which are states that were captured by, in the most recent elections, former Secretary of State Hillary Clinton. Nominal data, as you can see on the map, don't represent any sort of quantitative relationship between the categories, but rather they just show you which candidate captured each state. Ratio data, which you can see in this map here, are different in that you get a sense of quantitative relationships between the different categories. And so what we can see in this income by county across the United States in 2014 is the wealthiest counties have the darkest purples, and you can see in and around the San Francisco Bay Area and the northeastern corridor between Washington, D.C. and Boston, Massachusetts tend to be the wealthiest parts of the United States. You can see from the legend as well as those dark purples represent counties with median household incomes of $70,000 or more, that the median income is in many cases over twice as large as some of the white counties, the poorest counties in the United States. Briefly now, I'd like to cover how to work with this type of information in ArcMap. And so first and foremost, what I'd like to do is pull up ArcMap again, and if you don't have it open already, open up your Section 1 MXD document that we saved previously. You should see our world map, our geographic features on the map of the different countries of the world in the Robinson projection. If we go to the Add Data command, which you'll recall is this small black plus sign on your top toolbar, and click, we can navigate to our data folder and find this data set, countrydata.csv. We click it and we click Add. Nothing appears on your map because the CSV is interpreted by ArcMap as a table. It's not linked with any geographic information per se. To view the contents of the CSV, we right-click the layer, and then we click Open. This opens up the table. We can move the table into the screen here if we want to see it a little bit better. We see that the CSV has 4 columns. The first is TFR, which is the total fertility rate of the country in 2017. E0 represents the life expectancy at birth of a given country also in 2017. The time column tells us that the year is 2017. This is the same for every country. And the ISO 2C column represents a 2-character country code that we'll use in a later video to link to our country's data. What we can do with the CSV file certainly is view it. We can do some basic manipulation with it. For example, if I right-click the column header, I can choose if I want to sort the data in ascending order or in descending order. For example, I could sort in descending order. And I see here the country with the highest total fertility rate in the world is about 6.5. We could do the same for life expectancy. Right-click, sort descending, and we see that the country with the highest life expectancy in the world is above 89. CSVs are useful in ArcMap, but they're limited in that there isn't a lot of editing that you can do of CSVs inside of ArcMap. In turn, a good idea when working with tables in ArcMap is to create a geodatabase. We've talked about shape files in this video series to this point. A geodatabase is the native data storage format of ArcMap. Geodatabases can store all sorts of different data files. You'll learn a lot more about this in future videos, but it certainly can store shape data and also tabular data. Spatial data inside of a geodatabase are called feature classes, and tabular data inside of geodatabases are called geodatabase tables, appropriately. Briefly, I'd like to show you how to create a geodatabase by exporting our data from ArcMap. So we're going to pull up ArcMap again here, and we're going to follow a series of steps for exporting our data from both a shape file and from a CSV file to a geodatabase. So first and foremost, what I'm going to do is I'm going to right-click my country's data in the layers view in the table of contents. I mouse down to the data option and I choose export data. I'm going to choose to export all features, and I'm going to choose to use the same coordinate system as the data frame, which means that my layer will adopt the Robinson coordinate system that we've specified. For an output feature class, I need to specify a path to somewhere on my computer. I'm going to click the Browse button here, the little folder icon. I'm going to find my home folder. We also have that as a folder connection if we need to find it. Inside of there, look for the database icon in the top right, in the Saving Data window. This will allow you to create a new file geodatabase. I'll click it, and now I can name the geodatabase whatever I would like. I'm going to call it world_data and press enter. Now I have a new geodatabase named world_data. I double-click to enter that geodatabase, and now I need to choose a name of my new geodatabase feature class that I'll be exporting into the geodatabase from my natural earth shapefile. The name that I choose will be countries, appropriately. I click save, and then I click OK. When prompted if I want to add the exported data to the map as a layer, I click yes. Now my countries layer appears in the table of contents. I then follow the same steps for my country data CSV. I right-click the table, choose Data, Export. I navigate to my World Data Geodatabase. I'm going to name my new table Country Data. Click Save, click OK, and Yes. And now inside of my geodatabase, as you can see in the table of contents, I have both a countries polygon feature class and a country data geodatabase table. I'm now going to save my map document. And so what we'll learn about a little bit more, and kind of looking at our different fields as well, is inside of our different tables. Our tables are going to be characterized by different fields and then different field types. Generally speaking, in a GIS, we work with numeric data, which might be represented as integers or floating point numbers. We might work with text data, which are represented as strings, or we could work with dates or binary large objects, or blobs. Inside of ArcMap now, if I right-click my country data table and I click Properties, I can choose the Fields tab to take a look at my different fields. TFR, for example, when I click it, we see that the data type is double, representing a floating point number. The same is true for my life expectancy column. ISO 2C, we see the data type is text. This is going to be especially important for us in future lessons in that numeric columns allow us to perform mathematical operations on them, whereas text columns do not.